see.
Yeah, because I sent one of the unpowered wheels, so you could use
Put the
the
brake.
unpowered wheel there.
Oh no, put the powered one on there. You a powered wheelbarrow.
Yeah.
Figure out how to steer it though. See.
It's like a user assist. You just give it a little bit of force and then the electric wheel takes off.
Turn the throttle and let it go. Got a
Al,
lot
I
of,
heard. Oh, go ahead.
go ahead.
I was gonna say, Al, I heard you were tuning your local planner.
Ooh, tuning. That sounds like a really precise verb to use for what I was doing. I think a more precise verb would be something like, I was running a bunch of launch commands and trying to figure out if I was doing anything right. So
And were you successful by your self-evaluation?
no, to put it bluntly, I don't think I've not mastered yet how. I don't think I have the right launch file. I think it was left to me to write the launch file to get the Navsat driver, the let's see, what's that odom.py code, Matt, that you wrote, and then I also had, and so I don't think I got the sequencing right on those. So I've got to sort of put down on paper what needs to start and in what sequence and what are the right parameters, and rewrite that launch file, because I don't think I've got it right yet.
Sure.
So if somebody's got a launch file they want to share, I'm more than happy to plagiarize with pride.
So I guess you were missing your odometry. You were missing your Navsat driver.
Start Navsat driver. I'm missing heading. So I'm missing ODOM. ODOM wasn't there because heading wasn't there. And so whatever was supposed to produce heading, and I didn't take the time to figure out why wasn't heading there. Fix was there, so GPS was running, which was fine. Heading wasn't there, which then the downstream impact was ODOM wasn't there.
Okay. And I guess what sensor were you getting your heading from?
I think heading was coming out, or supposed to come out of that odom.py code.
Oh, which just wasn't running at the time because you couldn't
Right.
put it into your launch file. Okay.
I think so. I think it's as simple as that.
Sure. So do you know how to put a Python node in your launch file for next time?
I thought I knew how to do that the first time, but obviously not. Yeah, I mean, yeah, I can clumsily figure it out. Yeah, but it
Sure.
takes me. I'm slow about that stuff. That's why I say if somebody's got one that would work, then that would speed things along. He said, hopefully.
I mean, all I have is other examples that you've probably seen.
Well, I mean, so am I the first one to try to get the Navsat driver and this odom.py thing working together?
In real life, yes.
You're on the cutting edge, Al.
Say that again.
You're on the cutting edge.
Yeah, well, cutting, something feels pointy.
That's why they call it cutting. I don't know.
We'll get there. I think it's pretty simple. I'm hoping it's pretty simple. I just need some quiet time to sort of like work my way backwards and add the launch file commands.
Yeah,
just
shouldn't
posted
be
a
too
link.
difficult.
I posted a link to the NavSat driver that's on the GitHub account. And that's the one that we modified to output heading as well as your fixed message. So if you start the NavSat driver and you're not getting heading, then you may want to upgrade to this version.
So that, when you say upgrade, I have a local version of that running in my Catkin workspace and built that maybe a month ago. So is it something changed in the last month on this one?
Nope, it's still the same. And if you go out, you can see. I can show you. So this is out on the Ross Agriculture GitHub account, and then you can go into launch. And here is your launch file to start the node. And I'll just give you.
Starting this node is not, but this.
Go ahead.
Okay, so I started this one and this one didn't give me heading. Is this one supposed to give me heading, or is heading supposed to come from the, I'm trying to pull up the thread here, just a second.
Okay, so basically you just download this node. There are two parameters in this launch file that you may need to change based on your settings in your GPS. And that's your, what port it's coming in on, and then what's the baud rate. And then you can just launch this. And then that will give you heading and a fixed message. And I can show you in the software where that is. So you can take a look on your local version and then just make sure that you're just running this one. So if you, one moment.
GPS underscore odom.py. Don't I need another, isn't there a separate ROS run, or doesn't that need to be in the launch file as well?
So I just break it down into very basic steps. And the first thing that you want to verify in your system is that you are getting heading and that you are getting a fixed message and that those are accurate. And if you're not, then that's a problem.
Right.
So what I do is I basically just do one node at a time. Like right now, what you're working on is how do I get GPS data into ROS? And by GPS data, I mean you want your lat, long, and altitude, and then you want a heading message.
And I posted, I'm looking back at the thread, I posted my launch file and so it launched the NEMA NavSat driver, which was from the Ross Agriculture version, a month ago. So my suspicion then is the reason heading's not coming out of that is because, well, the heading's not coming out of that, and maybe it's because I had used the use RMMC and set that parameter value to true based on what I thought was the right conversation the last time we talked about that, but obviously wrong.
Generally just want to use the launch file that's in the example. And then if you don't like that, or if you want to modify it or add your own things, then do that. But first, let's just verify that launch file that's out there. If you start that up, just change what port number or port your GPS is, and then the baud rate, and then just start that launch file. And if that doesn't work, then we have a problem. And then if you want to create your own launch file, that's cool too.
Obviously, I didn't dream up changing that parameter. I think that came from one of our conversations on Friday. thinking, oh yeah, I need to change that parameter. So trust me, I wasn't like winging it. Anyway, I'll go back and change that. So hopefully that's my issue of why I wasn't getting heading out of that, driver. Make sense, Benny?
Makes sense. So once you get heading, then you'll be able to test that basic stuff. And I still haven't built that GPS to waypoint thing yet, but it's coming.
That's okay. I mean, because I still haven't, driven around with a joystick and watched it on RViz to make sure that RViz is, able to visualize it. So,
Right.
Lots of steps to go. We'll get there, one small step at a time. But I did learn that my tractor does not do well in the rain, and after about 2 minutes of rain, the steering motor sensor starts to get bad angles, and water in the magnetic angle sensor does not do well. So.
Hey guys, I joined in with y'all's group a couple years ago and helped out with, I think it was with you, Al, on a 3D printed gear that like there's some CAD work that we bounced a few ideas off each other. And then I had to take care of some work stuff, and I was away for probably about 1.5 years or 2 years, and just kind of checking in to see like what y'all have been working on, and if there's anything that I can do to help when it comes to the 3D modeling and the design. I'm nearing completion of the master's degree at Penn State in additive manufacturing. Got a lot of experience with the industrial 3D printers, so making parts out of aluminum and titanium and nylon, and then also the whole design for additive manufacturing. So how do you optimize something for the lightweighting, or for building in certain types of machines. So if there's anything that I can do to help out with that, I'd be glad to help out. And then the second thing I wanted to bring up was, and I don't know if this is going to be related with this group necessarily, but I was just kind of curious if y'all had heard anything about this, or if there's any interest in this. But it was to look at trying to automate beekeeping. And when you look at the work that goes into taking care of beehives, there's quite a bit of inspections and other types of process, taking care of the bees, extracting the honey, so on and so forth. And I was just curious if there is any interest in maybe trying to see how much can be automated in a beehive.
Wasn't there like a killer wasp or something going after beehives in California or something like that?
Yeah, I think there was, but then COVID scared it away. No, I don't know.
Have to get Matt's laser fly killer mounted on top of the bees and predators. Yeah, I think beehive automated running would be a really good application for automation.
I think so too. I think there's definitely a need for more honeybees in the United States and the world. And if one of the barriers to entry is just the maintenance of beehives, there might be an opportunity in trying to look at the beekeeping process. And I've spent the last couple of weeks just watching YouTube videos on beekeeping. So that's about the extent of my knowledge. But if there are ways just to reimagine that whole process to see what could be automated or what could be changed to make it more efficient, so that maybe having a hive of bees in not just a few places, but really all over the place in agricultural areas in particular, maybe that could really be a force multiplier.
So, I'm not an expert by any means, nor am I necessarily agriculturally gifted. But what I've heard about the bee problem, at least in the United States, is there's not that much biodiversity near the hives. So they're not getting, the quality nutrition that they need, so to speak. That's my understanding. And then number two is there's unexplained, there's some social disorder that's going on and causing these colonies to collapse. I'm not sure if any of those, I'm not sure if the problem really is the maintenance and the labor that it takes to maintain a bee hive, but rather some unexplained phenomenon that no one knows about, and B, just the land around it.
Yeah.
Automated flower planters that plants more flowers around the beehives, so they have a better food source. Would be part of it too. But I don't know. Looking at bee, I like honey, but I don't feel like comfortable like if I was going to do bee, keeping to wearing that outfit. If they had some kind of thing, you could just vacuum out the honey every week or however long they do it, and to just go pick up a pail of honey or whatever it is, that would be a lot better than pulling out those racks where the honey is and extracting it manually. That would be if you could automate that. That would be I think a big boon in people taking up beekeeping.
So there is a company that does that. If you look up Flow Hives, FLOW, they have they're out of Australia, and they have this special kind of honeycomb design where they each one of the little cells, it almost it kind of has two sides to it, and then they have a way to basically cause them to kind of open up halfway, and it drains the honey out. It's really a clever approach. And I was thinking something along those lines maybe would be the mechanism for the honey extraction. But some of the other issues in beekeeping, and again, my knowledge just comes from YouTube, so I'm no expert either. But there are issues with looking for for example, there are little mites that kind of parasites that get onto the bees. That there's maybe some sort of way to either identify those, track the percentage of those in a colony, or even reduce the likelihood of those getting in there. There's issues with making sure they have the right amount of nutrients, over the winter. And then there are issues if, when the colony gets to be so big, having to split that and then, move to other hives. And so, I kind of, and this has all just been kind of a couple ideas I came up with the last couple of days, but I was thinking of maybe just drawing out all the different aspects of beekeeping, and then just seeing where are the opportunities for automation or data collection. And the data collection can maybe be useful for identifying those social issues that are causing the hives or the colonies to collapse. So I mean, it just some thoughts. And I was thinking since this is a group that does a lot of work with automation in agriculture, this could be an interesting approach. You wouldn't have there aren't the risks of something driving away with GPS issues. The issues here would be a hive of angry bees going after people. So different challenges, but it could be an interesting endeavor.
A new take on swarm robotics.
Yeah.
As it relates to additive manufacturing, let me try to share a picture. Doing this with a chunky keypad. This is a little bit small, and I'll zoom in to make it bigger, but this is, can you see that steering motor?
Mm-hmm.
I mean, so just to get your bearings, this is the steering motor on a lawn tractor. This is what Matt and I typically call the half moon gear that's mounted on the base of the tractor. These are tie rods that go out to the front wheels.
Mm-hmm.
I'm going to zoom in here a little bit, and you're going to see that mounted to this potentiometer is that gear that this is the actual, metal steering gear. This was that gear that you helped with some time ago. I think there are awesome opportunities to, make this a more improved configuration. I mean, there's inside this steering motor is a nylon, I'm going to call it a nylon gear. It is some non-metal gear with bearings, and there's this shaft that goes through there, and that shaft is now connected to a U-joint. We've got a couple of different solutions. Matt's got, in an automotive setting, this is a U-joint that's specifically designed for, a car. This U-joint is a third-party U-joint that I've used. It would be fantastic to redesign that, this whole apparatus, and, what you see here is a kludgy process to affix a gear to this shaft, spin this magnet, pick it up on a magnetic rotation sensor, feed that into, an Arduino type device, and, get an angle out of that. It's getting the job done, but it, as you can see, is not highly engineered.
Yeah.
This mounting bracket, I mean, Matt has taken a very fast and effective, and it's not failed him yet, approach. I took an approach of, taking basically 3/4 inch angle iron and 3/4 inch tubing and having a welder make that for me. That could be, a 3D modeled and replicated with, additive manufacturing. And again, the notion is, if somebody wants to do 3 of these things and wants to build it in a weekend, having these parts ready to go and replicatable becomes easier if they're, if it's math data and spits out, as opposed to somebody's got to go chase down, a fabricator or using other processes. So there is, multiple brackets in this process. All, in my mind, are additive manufacturing candidates. Is my layman, uneducated, wishful thinking sort of perspective. There's also a bracket that holds the servo that, controls the transmission. There's also a bracket that holds the sensor, and we've got a couple of different approaches for holding the odometry sensor or speed sensor for the rear wheels. Again, those, let's just say round numbers, we've got 6 brackets that make up this thing.
Mm-hmm. So,
All candidates.
So Al, on that, there, just so I understand correctly, the potentiometer is towards the bottom, and then what is the sensor up at the top for?
Yeah, I have, we've all got slightly different approaches. I started off with I have 2 angle sensors. I think of it, one is high resolution and one is low resolution. The potentiometer on the bottom is analog and gives me 1,000 ticks, more or less, for a full left to full right. The one on the top is a magnetic digital sensor and gives me 30,000 ticks, full left to full right. We don't know yet whether 30,000 ticks is actually required to, to drive a straight line and keep it within a few inches on an AB line. If we could get away with, whatever this is, a $10 analog 1,000 tick sensor, then, that's probably a better way to go than a $15, well, it's probably a $30 when you add together the Arduino plus the sensor and stuff. So I've got two to get the job done, where ideally we only need one, but we're just testing.
Okay. So those, do they actually communicate with each other, or are you just taking two different values and then you're just kind of like deciding which one you're going to use for the angle that you're collecting?
The second.
Okay. Okay. So I think, yeah, there definitely are opportunities for additive manufacturing there. I think the bracket one, that one is like a really cool application in that, there are different types of softwares that you can use. One of which I like is called N topology, the letter N topology. And what's cool about it is it's all of the design is all math based. So you can create like a template, and then you just put in the numbers of, maybe the length, the width, and the height, the whatever, or certain dimensions you're looking for. And then it'll create this geometry of whatever you've created this template for. And what's unique about N topology is you can create structures with all the lattice in there. So you make really lightweight structures. So that's really impressive. The challenge is if you wanted to make a bracket of comparable strength that you'd want to use for something industrial, like, on a tractor, you probably would want to make that out of metal. And that would probably be like a, $1,000 to make a metal bracket like that.
Yeah. Probably don't want to do that.
I mean, like maybe you would, depending on the application. If you need something really lightweight, that would be like a satellite component, right? That would, it paid for itself in the lightweighting. But I think if we're looking to try to do something like kind of easy wins with more affordable additive manufacturing, maybe like the consolidation of part consolidation, or feature consolidation, where maybe you would have like a bracket that would have the sensor, but then also it would be designed in a way that it would fit really well into something and have another multiple functions. Or maybe we would design like a template for it would be meant to fit a certain XYZ type of sensor, but then depending on where it needs to go, we could adjust just those dimensions, so it's like a universal design kind of package for whatever that type of sensor is going to be. There could be some opportunities there. I wish the metal printing was cheaper, because it'd be awesome to make like that bracket you're talking about, where you where you had to have somebody weld that up out of angle iron, where you say, oh yeah, I've got, take the calipers out and measure it out, and then it comes up with the design 30 seconds later. That would be really cool. But it would be expensive to print those parts.
Yeah, I mean, it's probably not that. I mean, a good welder with a jig probably could knock them out fast too. It's just a sort of a pain in the butt for me anyway, to go find a good welder with the jig and get it repeatable. But Matt has demonstrated time and time again, just get what is it, Matt? A steel, stainless steel pipe strap, and Matt MacGyver's thing's a hell of a lot better than me. That's the difference. He can MacGyver better than me. So, But what would be awesome, now that I've watched Jeremy at OCI, I don't know if you guys have watched ROS2 and DDS video. Now I want to make all of the sensors DDS, and it would be cool to re-engineer that steering motor and integrate an angle sensor into it and make that angle sensor DDS.
Wondering where I could whip in the ROS2 conversation, but I'll save it for later. Good job, Al.
Just segueing for you, man. I'm just your wingman.
Just one last question about all that. The motors that are being used for controlling the steering, is it a single, vendor model of motor that you use, or does it vary?
I mean, what I'm working on is focused on this lawn tractor platform. And so in that particular platform, it is the Saturn Vue, Chevy Volt. Some people called it an electric pump, but it's an electric motor. And they might come out with different part numbers, but it's basically the same motor.
Okay. So if that's like a decided upon, if like the geometry of that is, fairly, standard, then maybe we could look into, redesigning the sensors so that they fit smoothly in that system or more effectively in that system. That could be a good use case.
Walter, you want to give us a ROS2 update?
No, just a fanboy trying to make it happen.
Keep pushing, keep pushing.
Never gonna give up.
I
Get it done.
I did some of the Foxy tutorials this past week, and it's a relatively smooth transition. I didn't find anything that was like crazy different in a bad way.
And I will just say, from the perspective of application in an industry, open standards and reliable communication, especially long distance comms, will start leaning towards something like a DDS implementation. So on my work side hat, that is a requirement we are pushing towards. So the fact that exists in there, and that's awesome, that's definitely a push. But as far as implementation, I'm gonna try and set something up like what I did with my that Sphero RVR, but I want to do it with ROS. But the problem is there's nothing built right now, right? With Foxy Tutorial, you're building it on what? Like your desktop, Vinny?
They have a Docker.
They have a Docker, so you can bring it down onto like a Pi or something if you wanted to, right?
Right, yeah.
Okay.
For DDS, does anybody have like a Hello World simple DDS sensor kind of thing?
Is that homework for next week for you? Us? You?
What is the most simple DDS sensor you can make?
Probably like a light sensor, right? Like,
Yeah.
That's
What would that look like?
I know nothing about DDS. I was just thinking Hello World and electronics.
Yeah. That's a wonderful sort of example.
I think
Anybody
any
seen that?
sensor, you're right, any sensor, like a anything that would,
Temperature,
temperature is nice and low. I mean, your
light, potentiometer.
I was going to say the pot's based like on what Al has there in his tractor.
I mean, Jeremy in his video, he mentioned he didn't say, like network sensing printers are DDS, but he used that as an example of a network aware device. So I'm like, hey, that'd be cool.
So I know nothing about DDS, but what is it running on? Is it running on a system on a chip, or? a microcontroller.
Kind of like well, I don't want to act like a pro, but I mean, if you're setting up comms between your two ROS nodes, ROS2 setup, it's like the communication. You're setting QoS and you're, basically a guarantee of delivery. You're controlling that. I think it's included, question mark?
So it's a network stack thing, not a hardware stack thing.
Correct. So he was saying a sensor would be a simple sensor to use to send across the DDS, like across a ROS2 setup, maybe, right? Or am I implying something? Okay, that's what I was thinking too. I mean, I was drinking the Kool-Aid.
I'm not educated on it, so it appeared to me that DDS effectively abstracts the complications of connecting a sensor to ROS2. So once you get a sensor to be DDS, sort of like, think of Bluetooth. If it can talk Bluetooth, anything that can read Bluetooth can talk to that. So I'm thinking, wouldn't it, if ROS2 talks DDS, how do we get our sensors to talk DDS? I'm just curious if anybody has seen anything in that space yet.
By DDS, you mean direct digital sensing, right?
No.
What does that stand for?
Haven't Googled it.
Yeah, I gotta do it. I sent a link in there to it's a doctor of dental surgery. Just kidding, not that.
I ran across that one also.
Data distribution service?
There you go. Joe Speed like wrote it or something. I mean, he's Mr. DDS.
Dude's like a lot of Red Bull. I can't find many more people excited about life than me. And then I meet someone like Joe, and I'm like, I got some levels to go. I chatted with him last week about some stuff. I was like, holy crap.
Yeah, MQTT and DDS are similar in nature, and I think he wrote them both.
I think it just comes down to the same thing, right? You just have to have something running on your sensor that allows that comm, right? So your sensor is going to be sending data to something that's going to be able to read it. So it has a ROS2 node-ish, and that's going to send that over to wherever the next connection goes.
The comparison to MQTT helped me because I've done stuff in MQTT.
Yeah,
So.
The little bit that I've read, DDS for real time better than MQTT. Believe it or not, and I thought MQTT was pretty damn good.
It's pretty easy to implement too.
Okay, sounds like we're all in a similar boat that DDS is a new animal, yet one more thing to learn. Shocking. There you go, Matt. Put it on the list. Yet one more thing. I thought it was just like the patent office. There was no new things to invent. Everything had been invented. Nothing else to learn.
Famous quote, yeah.
Lee, how's it going with your robot?
He's on mute, so he's probably talking and not realizing he's on mute.
Yeah. Or not paying attention.
Oh, hi, Wendy. I'm enjoying listening to you guys. The robot is well, I think stuck somewhere without making much progress. Let's see. I think probably I'm will to get the credential mark like driving the robots around. I think I am stuck there. The TF is not correct yet. Seems.
So you're having trouble extracting your TF from your fiducial marker?
Right. So
Okay.
the mark can be detected, but yeah, I think that's where I stop.
So
Okay.
your application can detect the fiducial marker, but you're not able to get orientation out of it for whatever reason?
Right, no.
Okay. I mean, I think, Matt, you're the most familiar with the fiducial to orientation.
Yeah, I
Um,
was about to ask Matt about.
Yeah, that fiducial package will output your pose.
So it outputs a pose and not a TF, right?
Right.
So Lee, is that the confusion? Are you looking for a TF where it's really publishing a pose?
The TF. So I think I can see the topic TF. So you mean I will still need another topic like a TF post, something like that?
Yeah, so a pose is different than a TF, where, TF stands for transform, I want to say. But you can take a pose in one map and a pose in that same map and then form a transform between one pose and the other pose. So you might, maybe something you're launching is launching that TF topic or node, which is doing something with that TF topic. But from what Matt's telling me is you might be wanting to look for a pose message instead.
Mm.
And you can visualize a pose message in RViz all the same.
I see. Yeah, yeah, I saw like Matt post a video earlier, like looks like it's doable, but just did not get through this yet. Yeah, we spend some time this week to see.
So it will, I can share the screen here. So when you run fiducial slam, it will, it kind of just has like this Raspberry Pi is just like the fixed position. And then when you move your marker around, that distance in between that fiducial 107 and Raspberry Pi cam, that's your transform. That's the distance between and the rotation between those 2 points. And that's all part of that package, the fiducial package. So it's just, once you start up that node, it will start to track that. And then if you have multiple markers, it'll give you the pose of each individual marker by number. Since I just had one robot when I was doing this test, I just had one pose. And so you should be seeing that data. In that tutorial, do they go over how to set that up? On
Yeah,
the Ubiquity?
this one looks like, yeah, I can get this. I can get this like the mark number, like 104, 107. I can get this. Oh, so if I have multiple mark detected, then suppose TF should be able to generate, right?
Yes. And then this is
Oh.
all the same things you need to do on a large tractor robot. So you can play around here. You can see this is the base link, and the base link is that fiducial. It's kind of the robot pose here. And so you can drive this around. This is just like your GPS information. It's telling you exactly where your robot is. You can see this little line going back. That goes to ODOM. So it's you need to provide a distance or a transform between your odometry node and then your robot. And that's kind of how it knows where you are on the map when you're driving around. And then you can just drive autonomous missions around and practice and learn the principles pretty easily and quickly. It's not the best robot, but it does all of the same mapping. If you need to build a map, the exact same transforms, learning pose, all of that type of thing.
Yeah, man. So let's say probably I only use one mark. So basically, I kind of hold one mark toward like above the camera of the robot. So I actually set up I think 8 marks on the top of the ceilings. I don't use that. So you mean if I have more than one mark, then the TF should be generated automatically if I launch this node, right? Theoretically.
So I did something a little bit different than the tutorial. So if you follow the tutorial, it'll tell you to put markers on the ceiling, and then you point your camera toward that ceiling.
Yeah,
and,
I did that.
And then it uses fiducial slam. So it gets the pose of each one of those markers, and then it does a slam on that and then tells you where your robot is. I wanted to do something a little bit different. I wanted to put the marker on the robot so we could practice multi-robots and do different things. I wanted to track things or practice tracking objects. So I did it kind of the reverse. I put the marker on the robot and put the camera on the ceiling instead of the other way around.
Right. Oh, that's interesting. So theoretically, like just follow this this tutorial, you just like a potential marks page should get the TF, right?
Yeah, I would keep doing what you're doing, put the markers on the ceiling, and then follow the tutorial and get familiar with what's going on. It's very useful.
So right, I can launch potential underline slam, potential underline with launch. So this one, like I can launch this program without no problem.
Yep.
So
maybe
maybe
a few problems, but yeah, it's supposed to work. It works on my machine. That's what you're supposed to say once you get it going.
Well, that's why I'm curious. It's supposed to be working because I see the image in your post, the video you post should be working, but my TF doesn't generate it. Maybe that's because I have only one marker.
Yeah, the slam. I think the slam needs at least 3. I'm not totally sure, but I think it needs 3 markers.
Oh, I see. Then yeah, I set up 8 markers on the top of the ceiling. When I'm testing inside in the evening, so I see something wrong, then I kind of did out the test out with the ceiling markers. Yeah, then I can easily put it outside and can test it.
Yep.
Okay. Cool, good to know. I was trying to figure out the problem there.
So it looks like I was wrong.
Oh.
Well, I think it's I should test it out actually. I just set up everything and then when I'm doing testing, I just hold one mark to try to see whether it works. But actually I should like test out with the setup as the tutorial told. Yeah, then should not a problem actually. Yeah, I will try it out to see how it work. Hopefully it will work as the video Matt posted. And then, so Matt, what's the, like with this little robot, what you are working towards right now? So
I was just playing around with fiducials. I was going to track different objects and put fiducials around the property just to see how it works. And then after I started playing around with it, I thought it was pretty useful because you have to set up the map, you have to set up your transforms, you have to do a whole bunch of stuff that you need to do with a bigger robot. So it makes it pretty easy to learn and play around with all of those items.
yes. So next, if let's say it can, so basically after it can autonomously navigate according to the coordinates of the potential marks, and then we can put the GPS. Let's say I have a RTK GPS and also the 3DR GPS. That's the next one to try out.
Yeah, that basically just replaces the fiducials. All that is, all the GPS does is tells the ROS where your robot is in the world. And the fiducial does the same thing. So everything else like your maps and your transforms and all of those things, you can still use those when you switch over from fiducials to your GPS.
I see. So basically in the RWiz, like gazebo, RWiz, you can like click the 2D navigate. Then you basically, you can direct the robot to different position, right?
Yeah, that's what I'm doing in this, in the video here. And it's funny, but there is a lot of software involved in doing an autonomous mission. You have the move base full stack, you're doing localization, you have all of the motor controls and sending commands back and forth. So what I do is you go up and click this 2D nav goal in RViz, and then inside of your map you draw a line, and wherever you click, that's the XY, and then wherever you extend that arrow is your yaw. And that is sending a message into an action server. So even with this little robot, you can use the 2D nav goal up here and click and point. But if you wanted to learn how to send in a message to an action server to move base, you can do that also. So like you could set in waypoints, like a number of waypoints, and then have your robot move around like a planning mission and go through a plan, all done in a very small space. It's a small robot, but all of the planning, all of the area coverage, all of those things you can just test just like this.
And
Right.
just to make the connection, you know, what Matt's doing in this video is basically what Al tried to do this weekend on his big robot.
But okay, that's great. So, but how? So I think in Alan's testing, probably you want to plan a mission, right? Let's just set a series of waypoints. So how to do it here, like Matt? Are we able to have a way to do it? Like right now, you are use the 2D levy kind of to manually define a point, but can we do a series of waypoints instead? Single one?
That's Vinny's arena.
Yeah, so you could define it a different number of ways. The way I will plan on doing it is, I don't know if you were there for my behavior tree tutorial. It was a few weeks ago, but I was going to plan a behavior tree for the different waypoints you would want to go to, and then robot goes to waypoint, returns success, and then goes on to the next waypoint. You can also just tell Ross, like, you can make your own node that publishes to the waypoint topic every 30 seconds, and asks the action server itself, hey, am I done? And then if I am done, then proceed to the next waypoint. So there are a different number of ways to do waypoints and quote unquote missions. But what RViz is doing is it's publishing to a topic, which is then being taken into the action server. So as long as you can somehow interact with that topic, whichever technique you use, you'll be able to do your mission.
Right, so is that the behavior tree basically contain a series of waypoint information?
It can do that, and that's what I was thinking of implementing, but I haven't done that yet.
Right, that's good. So last time I remember, I think Anna mentioned that, like, in the mission planning software, I think that's used for the Joom. So basically it has a text file. You define, let's say, first waypoint, latitude, longitude, or even altitude for the Joom. And then let's say how many seconds you want to stay there, for example. And then you define the secondary waypoint with its position information. So is this a kind of somehow can be implemented, or how to do it? I don't know.
Yeah, it can be implemented that way. From my understanding, there's no standardized way people define missions all throughout ROS. I think mission planning is where it becomes specific to your application. So whether you use a state machine, or whether you use behavior tree, or whether you simply read a text file of waypoints in a node and then publish to a topic, which is all your state machine or behavior tree is doing.
Oh, I see. So basically you need a program to, let's say you read the waypoints in sequence, and then publish it as a topic. And then the robot will kind of
Correct.
action on that.
Correct.
Okay. Just a low intuitive interface for that yet.
We've reached the top of the hour. Any more for any more? Christopher, great to see you.
Thanks for having me, guys. And definitely if there's something I can do to help out with the design for additive manufacturing, or if anybody wants to kind of bounce ideas about the honeybee stuff, definitely down for that.
Be cool. Hope you guys all have a great week.
Good week.
Yes.
Okay.
Woo!